This question is given in GATE 2008 in the subject digital. Now we'll see this question. For the each of the positive edge triggered JK flip-flop used in this following figure, the propagation delay is delta t. Which one of the following waveforms correctly represents the output at Q1? Okay, this is JK flip-flop 1, okay, and this is JK flip-flop 2 given. Here clock is applied, Q0 will be the input clock for the Q1, and they are asking what is the waveform for Q1, right? Now this is the clock pulse applied. This is the clock pulse applied with the time t. Now they are given 4 options. Due to some space constraint, I have written 2 options here and 2 options here. We need to find which one of the correct answer among these 4 options. Now coming to the JK flip-flop. JK flip-flop. Before starting into the question, we should know the truth table about the JK flip-flop. Now I will write the truth table for the JK flip-flop. This is J, this is K. J and K are the inputs for the flip-flop and this will be the output. If both inputs are 0, output will be the present state. Here Q represents the present state. Okay. Now for 0 and 1, it will be 0 or reset state. Reset state. For 1 and 0, it will be 1. This can be called as set state. For j equal to 1, k equal to 1, output will be q bar. It is called complement state. Complement state. So this is how we can tabulate the truth table for the JK flip-flop. This is one of the important truth table you should remember. Okay, I think we have seen this in the concept of JK flip-flop while we are teaching this digital subject. Now after this, you observe this diagram carefully. Here the values of J and K for both the flip-flops we are giving 1 and 1, right? Here for this also we are giving 1 and 1. Now this is the case where we need to see. Here J equal to 1, K equal to 1, output will be complemented. Okay. Now this is point number 1 to be noted, remembered. The next point is, okay, the next point will be, you see here this JK flip-flop act as divide by 2 counter. Okay, divide by 2 counter. What do you mean by divide by 2 counter is, the frequency which you are getting here will be the half of the clock frequency. Okay, so frequency at Q0, frequency at Q0 equal to f clock divided by 2. Similarly, frequency at Q1 equal to f Q0 divided by 2, because Q0 is the input clock for Q1. So f Q1 is equals to f Q0 by 2. That implies f clock by 4. Now as we know that frequency is inversely proportional to time period, it implies TQ0 is equals to 2t clock and TQ1 is equals to 4t clock. So by this we can conclude that for at Q1 the time period is equals to 4t from this equation. Okay, time period at Q1 equal to 4t. So if you observe the options, option A, option B, option C and option D, for options B and D, for options B and D, here the time period is 4t. Here also the time period is 4t. For no other like A and C, there is only 2t. Okay, so the answer must be present in either B or D. Okay, up to now is it clear? Right. Now we will see the how much delay is happening while we apply the clock pulse. Even though you apply j equal to 1, k equal to 1, even though you apply j equal to 1, k equal to 1, if you not apply any clock pulse, there will be no output. Okay, so you should apply clock pulse with j equal to 1, k equal to 1 to get some propagation. Okay, so clock pulse must be applied. Clock pulse must be applied. to get output. To get output. This is one of the important point you should remember. Now assume that clock pulse is applied. Now for the two JK, 1 and 1 is applied. Now at this point, since this is a practical scenario, there will be some propagational delay. Okay, it's not like an ideal situation. In the practical scenario, there will be some propagational delay, and the question is how much is the propagation delay? In the question, they represented as the propagation delay delta t. So when you apply the clock pulse with these inputs, up to here the propagation delay is delta t, and here also you are applying some input signal, right? For here also to come to here, there will be another delta t propagation delay. So the total propagation delay is delta t plus delta t. It will be 2 delta t. 2 delta t propagation delay will be there for the signal to move from clock to Q1, because from clock to Q0 it is delta t, and for Q0 to Q1 it is delta t. So you need to add, so total delay will be 2 delta t. So you need to check the propagation delay. See here, t1 plus 2 delta t. So option B is the answer. Whereas in the option D, it is only delta t. Okay, only delta t if the question would have asked like at the output Q0. If it is only Q0, then the answer would have been this. But in the question they asked Q1, so we need to check till the end. Till the end, the propagation delay is 2 delta t. So option B is the correct answer for this question.